Stochastic differential equations, we often write them in short as SDE. In this video, I'm going to construct an SDE object to represent a univariate Brownian motion of the form dx is equals to 0.2x dt plus 0.4x dw. The wt there is representing Brownian motion. So in some text, they write it as a b, but here in Matlab, we denote it by a w there. So what we have looked at before were ordinary differential equation, and we say that they model anything that varies with time. But incorporating randomness or white noise in the coefficients of the ODE gives a more realistic results. And when you incorporate this randomness or white noise in an ODE, and then we have the SDE, the stochastic differential equations. So to create that SDE object, I'll click on the return key. So the first step there is to create a drift and diffusion functions, because we want to write our object in the form dx is equals to f dt plus g dw. So to do that, I'll click on code here. Then for the drift function, I'll call it f is equals to, and then at, and then open parenthesis, and then it is a function of t and x. And then we are looking at this part here, 0.2x. So it's 0.2, and then multiplied by the x. So that's our drift function there. Then click on the semicolon there, press on the return key, then enter our diffusion function, which is the g is equals to. So it's at, then open parenthesis, and it's a function of t and x. And then we are looking at this part here, 0.4x. So it's 0.4, then multiplied by x, then put the semicolon. So I can just run so that the drift and diffusion functions are created. So the functions have now been created. I'll go on and click on the return key, and then now go on and pass these functions to the SDE object. So call it obj. So that will be our SDE object is equals to, then type in SDE, then open parenthesis, f, the one that we had just entered, then the g, the diffusion function, this one 0.4x, and then I can go on and run. So we have our SDE object there, stochastic differential equation, and we have the drift function, then the diffusion function. An SDE object enables simulation of vector valued SDEs.